Let's deal with this inequality first. If we find where 1.3 to the 2x to the power of 2x equals 80, that will be helpful. So if we do log of both sides, we'll get this, and then you can bring the 2x to the front, log 80, so 2x equals log 80 over log 1.3. Type that into your calculator. It doesn't matter which base you use. I use base 10. That gives 16.702, and then divide by 2. That's going to give us 8.35. Okay, so that's where that's a point where 1.3 to the 2x meets the line y equals 80. So if we just think about the other equation now, or inequality I should say, I think the best thing to do here is to sketch a graph of both of these modulus functions. If we just clear up a bit of space, so here's the answer to the first inequality. In order to sketch the graphs, we want to first of all sketch the graph. Actually, let's move it across a bit. Let's move it right down here. Okay, so if we want to sketch first graph, we want to sketch y equals the modulus of 3x minus 1. All we have to do is sketch the line 3x minus 1, y equals 3x minus 1, and then reflect it in the x-axis. So this is going to go through at -1. This will go through at -1, and it would have a gradient of 3. So it would go through here at the point 1/3. And so it's going to be a V-shaped graph. The y-intercept. The y-intercept would be -1 normally, but when we reflect it, it's going to become +1. So we'll get a V-shaped graph that looks a bit like this. Excuse me. So that is the blue graph is this one here. If we think about the other graph, let's draw it in red. The other graph, y equals the modulus of 3x minus 10. This graph it's very similar. It's going to be parallel, but the x-intercept is going to be 10/3 this time. So 10/3. It's going to have the same gradient. It's going to have the same gradient as the previous one. So I'm going to try to draw these parallel. Okay, that'll do. So that they meet at this point here, don't they? Now, in order to find the point where they meet, let's use a different color. So we want to find this point here, which is halfway between 1/3 and 10/3. If ever you want to find halfway between 2 points, you can just add them together and half them. So 1/3 plus 10/3 is 11/3, and then when you half 11/3, you get 11/6. So that point will be where x equals 11/6, the point where the graphs intersect. Now we want to find where, remember, we want to find where this graph is bigger than this graph, where the y value is greater. The y value is greater. Let's see if we can highlight this. The y value would be greater on this graph, on the blue graph here, well, all the way from here onwards. If you imagine this blue graph carrying on going up along here, it's always going to be above the red graph, whereas everything before this point, 11/6, the red graph would be above the blue graph. So we want all of these values here, all of these x values. In other words, this inequality is solved when x is greater than 11/6. So for this inequality, I didn't actually answer this question properly before, because I should have changed that to an inequality. This will be less than this when x is less than 80. So I should change that to less than. So when that is less than 8.35, when x is less than 8.35, this will be true. Okay, we found that 8.35 was the point where this was equal to this. So if x is less than 8.35, then this will be less than 80. Okay, so let's forget about that now. So where are our two inequalities satisfied? Well, we want both this and we want this. So the final answer has to be in between those two values. So x has to be less than 8.35, but it has to be greater than 11/6. So good question, that one. Practices lots of different skills there.